First, let us look at an example. At the bottom of the slide, we have trend of an important parameter of an equipment which has seen failure. So at the bottom there are two dotted lines, which is the range of variation of this parameter value. Let's say this is a temperature. So this temperature usually varies between these two limits. Now, if we look from the start, there has been a trend of increasing temperature. However, up to this point, the temperature was within its normal limits, and thereafter it shot up and led to the and shortly thereafter there was the failure. Now this is what typically happens. Although there is a chance to detect that there is something abnormal which may lead to an event like accident or a breakdown or a process upset, usually this is missed out for the primary reason that the parameter is well within the usual range, and it is known that the parameter varies within this range up and down several times without much explanation. However, it is possible to detect the impending failure much in advance if one knows that the value of this parameter is abnormal, and also there is a trend that the parameter is going in a particular direction. Now, in this example, this line shows the expected value of the parameter based on the physics and chemistry of the process, and this value also can be found out using an accurate process model. And what we observe is, the actual value is significantly different from the expected process value, and that points to the abnormal situation or the impending abnormal situation breakdown. Now, a quick note, a lot of people have a lot of models. Typically, a graph like the one which is above is shown that here is my model and this is the comparison with the actual values of the process. And, it is generally believed that if you see such a graph, it is a good model, excellent model. But if the same data is plotted in a different manner, which is at the bottom, which is sorted with respect to the actual value, one can see the extent of error in the model predicted values, and this is the extent of error which is the highest error, can be called as the accuracy of the model. Now that's the accuracy with which you can reliably use the model's recommendation, right? So it is possible to find out what is abnormal in the plant for all the parameters, and if the parameter is abnormal and it is having a trend going in a particular direction, then one can look at possible abnormalities in the plant physically or in terms of other parameter trends, and then decide. The first part is detection of abnormal, which is one activity, but the next activity is much more valuable and important, which is having known that there is something abnormal, then finding out physically or through other parameter trends what is happening physically, what has gone wrong. Let's say there is a hole in some equipment, so finding out what has happened actually, and then doing some action to avoid the impending event of breakdown, accident, or process upset. That is much more valuable. And if you see this period, which is the period of early warnings, it could be a few days and weeks, depending, of course, upon the particular process and the particular situation. Of course, there are few failures which happen almost instantaneously, and you can't do much about it. But there are many, and majority of the failures do give enough early warnings which are lost primarily because they are not thought to be abnormal, being in the usual range. Now, what kind of model you need for the job of detecting abnormal? So, the primary criteria is the accuracy. The accuracy of the model for various parameters should be, at least 1/10 of this range. This accuracy should not be more than 1/10 of this range. Such a accurate model can be used confidently to definitely identify abnormal parameters and not to give false alarms, that something is abnormal and actually there is nothing. It is waste of time looking around. So to give the authentic abnormal uh, alarm, one has to have that accurate process model. So a lot of people have a lot of models, and if you do have such a model with this accuracy, same thing can be used for detecting what is abnormal at some appropriate frequency of time, and one can act on it to avoid these events of accidents, breakdowns, and process upset to ultimately reduce the economic loss. If you do not have such a model, um, what we can do is we can discuss and confirm whether an accurate process model can be built for your plant. Remember, the model has to have some process intelligence, or it has to be a process model. Just checking limits and values of parameters statistically is of no use. So we can discuss and confirm whether an accurate process model can be built for your plant. Further, we provide expert service to scan all the important parameters in a plant. Let's say in a plant there are 100, 300 important parameters, and this we do every day using an accurate model and say, today these are the 4 parameters which are looking abnormal. Now, this plant could be a power plant or a CDU in a refinery, butene one in a petrochemical complex, ammonia plant, so on and so forth. So basically, we look at the whole plant every day and point out what is abnormal, and the engineer on ground can then decide the appropriate action or whether it is just a error in measurement. So how it works, basically you send an email with current parameter values of the plant every day, and we'll email you back what is abnormal, as simple as that. And the commercial part is also very attractive. We are not going to talk about the commercial offer here, but the main point is that after we have the discussion and confirm that the model can be built, we will actually go ahead and build the model and validate it. That is, whether the accuracy is good enough for this purpose. If the model is not accurate, you don't pay. Now, even if the model is accurate and you engage our services, you don't have to buy any software, you don't have to buy any services. It is just a subscription, so much of money has to be paid over a period of time for which you desire the service. And what is the cost of this expert monitoring subscription? Typically, for a plant like the CDU or the ammonia plant or power plant, it is less than the typical cost of housekeeping services for that plant. Every plant, there are typically contract workers who are typically paid minimum wage, 2, 3, 4 of them, who come and clean the plant. That's the level of expenditure which is involved in this exercise. Now that's what we do. What you can possibly choose to do is like this. So what we are doing is like we are a pathology lab for the industry. We are detecting abnormalities very reliably, very conveniently, and very cost effectively. Now you who have a lot of process and plant knowledge and you are present at the plant can be the doctor to diagnose what's happening and avoid accidents, breakdowns, and process upsets. If you think this is the approach which could be useful to you to avoid accidents, equipment breakdowns, and process upset, Please contact us today. These are our contact details. Thanks a lot for watching.